Hello everyone. Previously, we have discussed about dimensionality reduction and how to do it using PCA, its working principle. Today, let us focus on t-SNE, which stands for T-distributed stochastic neighbor embedding. It is also a dimensionality reduction method where it is used for visualizing high dimensional data. And unlike PCA, which focuses on linear transformations, t-SNE aims to capture more complex and non-linear relationships between data points. It is particularly useful when dealing with intricate data which has which in the data which has intricate structures. And let us understand how t-SNE works and what's the working principle behind it. Here, first, we have to find the similarities to joint probabilities. So, t-SNE converts the pairwise similarities between data points into joint probabilities, and these probabilities represent how likely is it for two points to be neighbors in the lower dimensional space. And by using that, it will minimize the divergence, where it minimizes the KL divergence between the joint probabilities of a low dimensional embedding and the original high dimensional data. To keep it simpler, it tries to preserve the relationship between points as closely as possible, and it is a non-convex cost function, which means unlike PCA, t-SNE has a non-convex cost function, which uh, which is like it has like for different initializations, it can lead to varying results, and therefore it is essential to use other dimensionality reduction method like PCA first and then reduce the dimensions using t-SNE. Here, the hyperparameters in t-SNE are the perplexity, which determines the number of nearest neighbors considered during the optimization, and the early exaggeration, which controls the spacing between natural clusters in the embedded space. Then comes the learning rate, which balances the trade-off between preserving local and global structures, and then the maximum iterations. It limits the optimization process. Since we have understood what is t-SNE, how does it works, and what are the parameters to consider, let us see how we can implement that using Python. First, input all the required libraries, and then we are loading the data, the MNIST dataset from sklearn.datasets. Then we are standardizing the input and transforming it into a scalar form. From there, we are creating the t-SNE model with the number of components are 2 and the perplexity is 30, with a learning rate of 100, and the maximum iterations that this algorithm should run is defined as 1000. And then we have fed the data into the t-SNE model, and finally we are visualizing the data. And here, since we already know we have like 10 classes, each class, like in the MNIST data, the final classification classes are from 0 to 9 digits. So we have 10 classes, and here each color represents the identification of each class respectively. And finally, like t-SNE is can be very valuable for complex data structures, and t-SNE is very expensive. So before doing that, we have to keep in mind that we have to pre-process the data and like choose the appropriate method, the appropriate parameters like the perplexity, the number of iterations, learning rate, and all, and then interpret our results. There are like many use cases of t-SNE, and one of which that I wanted to mention was by applying t-SNE to movie transcripts, we can uncover the hidden thematic uh, clusters or the interactions between the characters. Thank you.